Hello friends, welcome. Friends, pleasantly in the morning I saw this news article which talks about an Indian company set to launch first private satellite broadband service, and it is going to be India's first. Now I was pretty excited when I saw this news and I started investigating and going deeper into the details of what kind of empowerment and capability that this satellite technology will have. So when I went to this article, this is a business standard article, and you can see the headline is Ananth Tech to set India's first private satellite broadband services, and they already have got approval from ISRO, the INSPACE, not to launch 3,000 crore satellite broadband by 2028, marking the first India's private satellite rollout to the rival Starlink, OneWeb, and Amazon. Now, if you go down below, you will notice that there are certain data points which are mentioned. It talks about a 4-ton geostationary satellite that will deliver data capacity up to 100 gigabits per second to the users across the country, and the initial investment will be 3,000 crores, has been committed to the venture with the scope of further funding depending upon demand. So this is the news report. Now, friends, when I went through this whole article, it came to my mind that it is important now to let my viewers know that what is this satellite technology and how it is different from Starlink, and what kind of limitation, if any, it has, and why Starlink is going the LEO path, and what kind of limitation that exists if you go the GEO path, means geostationary satellite. So for that, friends, I did a PowerPoint slide, as I always do, to structure my thoughts, to make those thoughts much more clearer. And so this is the title of my presentation: GEO versus LEO satellite broadband. Can Ananth Technology compete with Starlink? Is that the purpose? And what is the purpose, if any? So we will discuss each and every aspect of it: the capacity, the business case, the flexibility, throughput, how many customers it can support. Every aspect will be compared. So please, be with me till the end of this presentation and you will learn a lot. To me, the subtitle of this presentation, it is a strategic technical comparison. It's important to understand that the technical comparison is going to be a holistic and with a clear-cut lens of how strategically it is important and whether it is going to bring any value for India or not. Now, the snapshot of the project is that Ananth Technology is planning 4 geostationary satellite. I think 4, I do not know the number, but it doesn't matter. It is geostationary satellite, probably in the Ka band, which is 27.5 to 30 gigahertz. That also I'm not too sure. I'm just speculating. Each satellite can offer up to 100 Gbps. Now, since I do not know how many satellites they are going to launch, because here it talks about company plans to deploy 4-ton geostationary satellite with a data capacity of to 100 gigabits per second. So I'm just taking, I know that there could be 1 satellite, 2 satellite, 3 satellite, 4 satellite. I do not know how many of them. Assume that there are few satellites, right? Per satellite, we have going to have a capacity of 100 Gbps per second. Gbps means this much amount of capacity the satellite will be able to serve to the users under the footprint. It is going to be at the orbit of roughly 35,000 or 36,000 kilometers, because this orbit is important. Why this orbit is important and this height is important? Because in this height, the orbital angular velocity of the satellite is directly resonating with the angular velocity of the Earth, and therefore it appears stationary from the surface of the Earth. That is the reason why this orbit is important. It is not moving with respect to the Earth, and that's why with fewer satellite you can cover the full subcontinent of India. At least India's footprint, India as a country can be covered by few satellites, because these are geostationary and have got very, very large footprint compared to LEO satellite. Now, Starlink has got thousands of LEO satellites. Few will be visible on the surface of India, on the top of India at a time. Initially, it will be 40. If you look at my earlier video, you'll find that I made a prediction that, well, they will start with 40, and as they move forward in time, in later years, that number can go up to 80 to 100. Why 40? Because these satellites, these thousands of satellites, are circling around the globe. They are not stationary, unlike in case of geostationary satellite, which is stationary, at the horizon. When you look at it, it will appear stationary. But the Starlink satellites are all continuously moving, and therefore, even though they have got thousands of satellites at a time, 40 numbers of satellites approximately will be visible on the surface of India, right? Above the surface of India, right? Not at the surface, above the surface of India. Means they will cover India using 40 satellite approximately at a time. Aggregate capacity, what they have mentioned in their press release, which I saw in one of the article which DOT official was quoted, they will start with 600 GV aggregated capacity of all the satellites, and it will go up to, if you look at my earlier video, which I'm going to show my Excel sheet, it can go up to large amount of capacity depending upon how many satellites will be visible, how many satellites are going to be available above India. So if you look at this 44 numbers, and then I am predicted 96 numbers, so I have calculated the total system capacity, right? Starting from 3520 Gbps, because this is going to be, as soon as they expand to the full capacity, they will have 3520 Gbps, and then when they have got around 100 satellites, it will be 7680 Gbps. Depending upon what the satellite capacity is, I am assuming that it will be 80 Gbps per satellite. Whereas in case of Ananth geostationary satellite, they have assuming 100 Gbps, which is ballpark in the same range. It does not matter whether it's 80 or 100. I just made an assumption of 80 Gbps. I could make an assumption of 100 Gbps also. It all depends how much bandwidth you have been given to transmit at a point of time. So I am assuming that both of them, Ananth as well as Starlink, will have a downlink bandwidth of 2 gigahertz, that is 2000 megahertz, and the uplink will be around 500 megahertz, right? So orbit is going to be low Earth, 550 kilometers. Now spectrum allocation, as I already mentioned, downlink 2 gigahertz, uplink 500 megahertz. The bands are also mentioned. Starlink is going to be in Ku band, Ananth is going to be Ka band. Both will be operating under, if they are offering commercial services, they have to pay a 4% AGR spectrum fee. Now, custom reach and frequency reuse. Now, why? And now we are going to talk about why LEO and why not GEO. Why Starlink has gone the LEO path and why they have not gone the GEO path. Because when you are doing LEO, the density of the satellite over the surface of the Earth in a particular geography can be very high. In case of GEO, the density is going to be pretty low. You can't have more than few satellites, couple of satellites, maybe 3 or 4 maximum, because those number of orbital slots are not available. But in the LEO, you will have a huge density of satellites. So what happens is, because the density of the satellite is going to be higher, in case of LEO, the frequency reuse capability increases. For example, if you have just one base station and you have, let's say, 2 gigahertz of spectrum available, assume that the satellite is acting like a base station, then your capacity will be limited to 2 gigahertz only, because the footprint is going to be only serving that satellites, that is available, this spectrum that is available, right? Whereas if you can divide the footprint into multiple such footprint, then what you are doing is you are aggregating a small space of geography where people will be able to use the full 2 gigahertz of bandwidth downlink, and then such spaces, small spaces, is going to scatter over the country. So that is called frequency reuse. So instead of having a large footprint, you have such smaller footprint served by those multiple satellites which are visible over the horizon of India at a time. That makes the capacity significantly higher compared to a GEO satellite. That is why Starlink's LEO architecture will be able to drive more capacity compared to a GEO footprint, where Frequency reuse is going to be limited because the footprint is going to be very large. Means that 2 gigahertz of bandwidth have to be shared among large number of people. Whereas if you are doing a LEO, the footprint is small number of people will be sharing 2 gigahertz of spectrum downlink at a time, and then in the neighboring geography, another set of people will be using the same block of spectrum. That is called frequency reuse. And that is why, if you see that if you have just 100 gigabits of capacity, you will be able to support roughly around 10,000 users with 70 Mbps busy hour rate or 20:1 oversubscription. Means if you are going to design the system for an oversubscription, means let's say you take 100 subscribers, but you assume that only 20 subscribers are using the system at a time, then you don't design the full system for all the 100 subscribers active at a time. That will make the system the number of people that you will be able to serve will get limited, and that is not going to resonate with practical reality, because in practical reality, all 100 people will not be able to will be using the satellite bandwidth at a time. So sometimes, we can use a ratio of 20:1, 30:1, 50:1, depending upon what kind of design criteria that you use and what is your customer usability structure is. Means what kind of customers that you acquire. Depending upon that, this user numbers are going to change, right? So this is how customer reach and frequency reuse is kind of a trade-off between a GEO and a LEO footprint. Now, the critical question here, right? If you go for a GEO, satellite system, and if you go for a LEO satellite system, which system is more consumer friendly from an economics point of view? And now this is the difference, the key difference comes. Even you can say that, look, I got 4 or 5 satellites, I can cover those customers. How does it matter? But the key thing which matter is the end user terminal complexity and price, and how easy it is to configure the end user terminal. Now, if you look at Starlink, it's a flat phased array radar terminal, which actually is very easy to use. And I'm going to show you why I'm saying that. So I'm going to bring this and I'm going to show Starlink's. You look at this. This is flat. You see? And it is very easy to configure. Why it is easy to configure? Why it is so, simple? Because the signal from this device, right? First, it has to travel lesser distance, 550 kilometers, compared to 36,000 kilometers in case of GSO. Second important thing is that the RF beams that are emanating from this satellite actually are steerable electronically. What does it mean? It is not static in case of a GEO. So let's assume that it was a disk, and if you are transmitting like this, and if the satellite is hanging in the sky stationary, then the RF beam has to be fixed. It is not steerable. But here the RF beams are steerable because it has to track the fast moving satellite. So it has to keep tracking the satellites, and then there will be another satellite which is going to hand over. Let's say if this satellite goes off the horizon, then another one will take off. So this RF beam is going to keep tracking, and then suddenly it is going to hand over to the next moving satellite, right? Which is taken over from the earlier satellite, which has moved away from the horizon, right? So that is the reason why this device is very simple. That power transmission requirement of this device is lower because the distance that this device has to travel to reach the satellite is 550 kilometers versus 36,000 kilometers. And that is why when you are going to use Ananth satellite geostationary, this is going to be a very bigger disk, maybe a 1 meter size. And it has to be pointing straight to the satellite. So you can't even miss in 1 degree misalignment. It has to be in minutes and seconds. Means you understand minutes and seconds, right? In degree. So so when you have got the circle has got 360 degree, right? And then 1 degree can divide it into minutes, and then the minutes are divided into seconds, like that. So the alignment in case of Ananth's geostationary satellite has to be so accurate. I'm going to show you, then you will see. This is the geostationary satellite's disk. It has to be so accurate that it hits the satellite accurately, because this is geostationary. Whereas in case of the Starlink, this user terminal is very flexible. Even if it is tilted slightly here, doesn't matter, because the beam is steerable to the satellite. And here the configuration has to be very accurate, and therefore it can't be installed by an individual. Some expert has to come, and then it has to be configured in such a way that it points straight to the satellite. And it has to be very big because the power levels have to be higher so that it can reach up to this 36,000 kilometers. Otherwise, you can't reach, right? And therefore, the user terminals in case of Starlink satellite, which you just saw here, is very, very simple, and it can be battery powered. Here you cannot have those things battery power because it has to transmit at a very high power, right? So that is the difference here, right? You see, large K bands, a dish is going to be very, very high, almost like 1 meter, and then it requires skilled installation. It can't be done by anybody cannot just do it. It may be expensive depending upon how it is. And the Starlink is going to be a flat phased array. It call it phased because the beams can be steered using electronically by changing the current, which are in which the antennas are fed by different currents of different phase angles, right? So it's a plug and play kind of solution. Electronically steerable, self-installable, mass production, enables scaling. Now, impact of service rollout. Because the geo terminals are costly and inflexible, relocation requires reinstallation, and that is going to be a big problem. Not suitable for mass deployment. LEO terminals are portable and consumer friendly and can be installed like a home Wi-Fi router, enables large scale adoption. Additional technical limitation of GEO, because the distance is very, very high, 36,000 kilometers, therefore for GEO, the latency is going to be very high, almost like 0.5 seconds latency. And therefore, voice communication, if you try to do voice communication, this latency is going to kill you. Means try to make a WhatsApp call using a Wi-Fi, you will really find it hard because 0.5 second latency is kind of measurable, right? You will find that when you start talking to somebody else, therefore, if anybody use Inmarsat voice telephony, you will always find it you have to wait for the other person to respond. You can't continue to keep talking, otherwise there will be spillover on each other's speech. And that is where the problem is. And latency also harms because if you send a ping command to a website server, you may not get a response as quickly as in case of a LEO satellite. And these satellites are very heavy and they are very costly to launch, right? And therefore the cost and maintaining the satellites are pretty difficult because this has to be powered using large, solar cells so as to serve the requirement because the satellite is at a very great height from the surface of the earth. Now, since the satellite has to also transmit at high power so that it can reach the antenna which is on the ground, and therefore the batteries and the solar panels have to be properly configured so that satellite can have a large life. Otherwise, it is not going to serve the purpose, right? So that is the problem with this, and the spectral efficiency is also going to be a problem. So they are talking about 100 Gbps. I'm not too sure whether 100 Gbps can be met using the same block of spectrum because in case of LEO, the retransmission cost. Let's say if you transmit, I'm going to show you the figure. Here, assume that you're transmitting to the satellite, right? Let's say this is LEO, right? You're transmitting to the satellite. Because this distance is less, if packets fail to reach the satellites, you can request a retransmission because this is only 550 kilometers. This distance is only 550 kilometers. So the retransmission cost means the distance that it travels is less. Velocity of light it will travel. So retransmission cost is less. So you can use signals which are at a high bit rate. Even if you lose signal, you can call for retransmission. But here you can't call for retransmission. Why you can't call for retransmission? Because the distance is pretty large. This is 36,000 kilometers. Therefore, you have to use a bit rate which is of lower QAM. And therefore, your spectral efficiency is going to be hit in case of geostationary versus a LEO satellite, right? Configuration. Right, so spectral efficiency is going to be a problem, and redundancy and resilience. GEO is a single point of failure. LEO is a mesh routed dynamically. So commercial viability, Ananth model unsuitable for residential use because residential people will like to have more flexibility. They will not have that flexibility. You have to call for configuring those disks, and then any misalignment where you will lose the satellite connectivity. It is targeted for government, enterprise, rural backbone, something like that, right? Rather than for commercial purposes, for residential purposes. Starlink model is affordable via economic scale. ARPU may be around 4,000 to 7,000, not clear how much, right? Everybody is calling out different ARPU. Geo model can match LEO pricing without subsidies, right? Because the devices have to be very, very large, and you can't really match the price of LEO satellite terminals on ground. So, but irrespective of everything that I spoken about, this initiative of India and Indian companies is pretty, laudable, because it kind of gives a option for India, right, to have their own satellite system in case of war, in case of natural disaster, in case of any geopolitical tension. You can't be dependent on Starlink because it's a foreign company. So you need to have a company which is Indian, so you can have more control of that company than depending upon Starlink, who can stop their services anytime, whenever they want, in case if there is a war or some kind of geopolitical tension. That's why Geo has to complement. This is very important. This initiative is laudable because of the fact that it is Indian system, which is under the control of Indian government and is an Indian company. So final takeaway is, identical spectrum is not identical performance. Key differential is terminal economics, reuse of spectrum, reuse efficiency, deployment cost. LEO wins for scale, consumer adoption, and operational ease. Geo is best suited for strategic and sovereign and niche roles. So that's all, friends, in this video. I hope that you understood the difference between Geo and LEO, where this announcement fits. Whatever, today that we saw the announcement that where it fits. And then with Vysat partnering with BSNL for voice connectivity, I just gave a segue, is not suitable at all, because this Vysat partnership with BSNL is not about data, it's about voice. And for voice, you cannot have a geostationary model. And I'm going to talk more about that. It is just a segue, right? Just a placeholder, that though Vysat is partnering with the BSNL, I don't think this is useful, because this is not for data. This is for voice in a low frequency band using commercial devices. And for voice, geostationary model is a complete failure. It does not work, friend, because of the latency, right? You can use data, and therefore the Ananth thing is much more useful. It is not bad at all for India, in spite of the fact that there are so many differences, so many advantages that a LEO model has. But Geo model for data purposes is not that bad. It is useful, and India should really be looking forward to this launch and rollout of services. Thank you, friends, for your time. I hope that you like this video, and thanks for watching till the end. And I'll come back with a new video on a new topic next time. Thank you very much, friends.